In this section, I'm going to talk about non-augmented matrices. So we just spent a couple of sections focusing on augmented matrices, but here we're going to deal with non-augmented matrices. And we're going to talk about some matrix operations that you can do with these matrices. So let me just remind you how you identify the size of a matrix. Remember, this is a 3 by 2 because it has 1 row, 2 rows, 3 rows, and then 1, 2 columns. This is a 2 by 2, 2 rows, and then 2 columns. This is a 3 by 1, a column matrix, so it's got 1, 2, 3 rows, and then it's only got 1 column. And this is a 1 by 4, it's got 1 row and 4 columns. Okay, now matrices can be added and subtracted and multiplied by a constant. And you can also multiply two matrices together. But some of these operations can only be formed between certain matrices. So we need to make sure we read the fine print. So let's talk about matrix addition. And actually the rule for addition and subtraction are the same because subtraction is just a form of addition. When you subtract two matrices, you're just adding the opposite of one of the matrices. So notice what it says here. Two matrices must be exactly the same size. Alright? So if they're not exactly the same size, just say that the operation is undefined and be done with it. So the operation is undefined if they're not the same size. So adding matrices is probably the easiest thing you're going to do. The first thing you do is check to make sure they're the same size. So if I want to add these two matrices, notice that this is a 2 by 2 matrix and this is a 2 by 2 matrix, so obviously you can add them. Now all you have to do to add them is add the corresponding entries. So in this matrix, the row 1 column 1 entry is A, and in this matrix the row 1 column 1 entry is W. So to add them, just add the A plus the W. And then here the row 1 column 2 entry is B, the row 1 column 2 entry is X, so just add B to X. And then here the row 2 column 1 is C, and the row 2 column 1 here is Y, so you add C plus Y, and then likewise you add D plus Z for the final entry. Okay, so now that you know how to add them, you should see it's pretty simple. So here, first of all, this is a 1, 2, 3 rows by 1, 2 columns, so this is a 3 by 2. And this is also a 3 by 2. So both of these are exactly the same size. Since they're exactly the same size, I can add the matrices. So it says to add this matrix to this matrix. And so all I do is take -1 and add it to -2, and you get -3. And then you take 3 and add it to 2, and you get 5. Then you take 0 and add it to -3, and 0 plus -3 is -3. And then you take the 1 plus the 2, and you get 3. Then you take the 2 plus the 5, and you get 7. Then you take the -1 plus the -2, and you get -3. And voila, there you have it. Now notice here, the first matrix, the size is a 3 by 2, but the second matrix is actually a 2 by 2. And since the sizes are not exactly the same, then this sum would be an undefined quantity. So you can't add those together. Now subtraction is just like addition except you subtract. So here we have a 2 by 2 and we're subtracting from it another 2 by 2. So since the matrices are the same sizes, we're allowed to do the operation. So just take 3 minus 5, and 3 minus 5 gives me -2. And then you take -1 minus -3. Now be careful when you're subtracting, because remember you have to change signs when you have a minus times a minus. So -1 minus -3 is actually -1 plus 3, which would be 2. And then here we have 2 minus 4, which is -2. And then again we have 0 minus -1, and 0 minus -1 would be 0 plus 1, which is 1. And then here, if we subtract these two, you have -2 minus -1. Well, that's going to be -2 plus 1, which is -1. And you're going to have 3 minus 2, which is just, of course, 1. and you're going to have 0 minus negative 3, which is the same as 0 plus 3, which is 3. Then you're going to have 1 minus 2, which is negative 1. And then 2 minus 5 is negative 3. And then minus 1 minus negative 2 would be minus 1 plus 2, which is 1. And then, of course, again, since subtraction is a form of addition, you can't subtract these two matrices because their sizes are different sizes. So that's how you add and subtract two matrices, of course, given that they're the same size. Now, you can also multiply a matrix by a real number, and this is sometimes called a scalar because it scales the matrix. So, for instance, if you were asked to multiply a matrix by the number 5, you would simply multiply 5 times each entry in the matrix. So 5 times this matrix, you would just say 5 times negative 1 is negative 5, 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15. I'm not sure why that's there, but anyway, 5 times 3 is 15. Now, here's another example. I'm going to multiply this matrix by the number negative 3. So again, just multiply negative 3 times each entry. Negative 3 times negative 2 is positive 6. Negative 3 times 3 is negative 9. Negative 3 times 0 gives me 0. Negative 3 times 1 gives me negative 3. Negative 3 times 2 gives me negative 6. Negative 3 times negative 1 is positive 3. Now, we can also do a linear combination which combines the multiplication and the addition and subtraction properties. So, for instance, here it asks me to take 2 times this matrix and then subtract 4 times this matrix. Okay, so the way I'm going to do this is I'm going to multiply this matrix by 2 and multiply this matrix by 4, and I'm going to leave the negative out here. Now that's important to understand because another way to do that would be to change this to plus, but if you do that, then you would have to multiply everything in here by negative 4. But I think it's easier just to leave it as a negative, as a minus, and then multiply everything by 4. So if we multiply everything here by 2, that's just going to double all the values. So we'll get negative 4, 6, 0, 2, 4, negative 2. And here we're going to multiply each value by 4. So negative 1 times 4 is negative 4, 2 times 4 is 8, negative 3 times 4 is negative 12, 2 times 4 is 8, 5 times 4 is 20, negative 2 times 4 is negative 8. And then I'm going to do the subtraction operation. And so when I do the subtraction, I get negative 4 minus negative 4, which is negative 4 plus 4, which turns out to be 0. And then I get 6 minus 8, which turns out to be negative 2. And then I get 0 minus negative 12, which is 0 plus 12, or 12. Then I get 2 minus 8, which is negative 6. And then 4 minus 20 is negative 16. And then negative 2 minus negative 8 is negative 2 plus 8, which is 6. So that's the operation there. Now I gave you some practice problems here that you can practice on, just a couple of small matrices. Here's matrix A, here's matrix B, here's matrix C, and here it asks you to find A plus B. So you can do that, add these two together, and just check and make sure you get the same answer I got. And then you can do B minus A, so take the second matrix minus the first matrix and show that you get this. And then here you're going to show that A plus 3C is undefined. And then here you're going to do just 3 times A and show that if you multiply matrix A by 3, you get this matrix. And then lastly, you're going to do 2 times A minus 3 times B and show that you get this matrix. And so you can do those as practice, so by hand. Now, one thing I do want to mention is you can do these matrix operations on a calculator, but that's only if you know how to enter a matrix into your calculator. And then if you do know how to enter a matrix into your calculator, you can actually do these matrix operations. But it does take, there is a bit of a learning curve if you do them on the calculator, but it can be done. I just don't teach it in my courses. In the next section, I'll talk about how you can multiply two matrices together. And here we did a multiplication, but it was only where we multiplied a matrix by a real number. But in the next section, I'll talk about multiplying a matrix by another matrix.